Hadoop consists of two key elements. It's included on the big data appliance for storage and processing. So a very quick overview of Hadoop is, if you want to describe Hadoop in a sentence, it's a means of providing distributed storage and processing of data using commodity hardware. So the Hadoop distributed file system is for reliable storage of data, and then the Mapreduce framework is a method for processing data in a distributed and parallelized manner. A Hadoop cluster is a set of machines networked together. Each machine is known as a node. Each node runs one or more of Hadoop daemons, and nodes can be classified as master nodes or slave nodes. The big data appliance provided by Oracle and Cloudera is a Hadoop cluster in a box with all the hardware pre-selected, all the networking information pre-selected, all this configuration all provided for you. And then the nodes are just rack and roll and turn on. Very high-level overview of HDFS. Has a Hadoop distributed file system storing files basically by splitting them into blocks and then replicating the blocks 3 different times and moving those blocks around the cluster for reliability and availability. Hadoop block sizes are geared towards large files. So the Hadoop default is that each block is 64 megabytes. For a typical installation, Cloudera recommends increasing this to 128 megabytes. And for the big data appliance, actually, the Hadoop block size is 256 megabytes. This decreases the memory available, or the memory requirements on the master, increases the amount of data that can be stored in the cluster, and also increases the workload of every mapper, allowing the cluster to be more fully utilized. You have a master node that holds information on the files in the file system, including where each block resides. That master node is called the name node, and the HDFS metadata lives in the name node. The file system itself, HDFS, requires 3 daemons. There are 2 master daemons. One is called the name node. The other one is called the secondary name node. You have only one of each. The name node holds metadata about the files stored in the file system and directs clients to the correct node in the cluster to read or write data. So that when a client wants to do a read against a file, the first thing it does is talk to the name node, and the name node tells the client where the machines are that serve that data, and then the client directly connects to the machines in the appliance and performs the operation. There's another master function called the secondary name node, which performs housekeeping functions on the name node. We're not going to get into a whole lot of detail about how this works. We're going to refer you to our administration course and our Hadoop overview course for that. In HDFS, there is one slave daemon. It's called the data node. It's responsible for storing and retrieving blocks of data. And there's one data node on every slave node in the cluster. So already you have 3 different processes and lots of instances of one process to manage. And then once you have the distributed storage capability, then you have the distributed processing capability in Mapreduce. Mapreduce provides a method for processing data in the cluster, and there are 2 phases in a Mapreduce job. Phase 1 is called map, phase 2 is called reduce, and these phases are run in parallel on multiple machines in the cluster at the same time. Every map process handles an individual block of data. So in the case of the big data appliance, an individual chunk of 256 megabytes is handed to a mapper and executed at the same time across the cluster. And then intermediate results are passed to machines, which then run the reduce phase, and the final result is stored back into HDFS. So you have the map phase, which runs in parallel across the cluster, and then you have the reduce phase, which runs in parallel across the cluster, and the output of the job is stored in our distributed file system, HDFS. Mapreduce has 2 daemons. There's a master daemon called a job tracker. This is responsible for receiving jobs from the client and splitting work out to all the slave nodes. Every slave node runs a daemon called the task tracker. The task tracker takes care of running the Mapreduce tasks that it has been assigned by the job tracker.